Example 1, similar triangles. Calculate, these two triangles are similar, use that information to calculate EF. Put an X beside the missing length. Now, scale factor is the first thing that we calculate. And we can calculate the scale factor for enlargement or reduction. I'm going to calculate the scale factor for enlargement, which means we're starting with this shape and we're finishing with this shape here. What I could do is put an I for initial length. This is the initial shape and this is the final shape. The formula for scale factor is final over initial. And the whole formula can be abbreviated to SFE for enlargement equals F equals F over I. Now, we need to make sure that we get the correct sides. What we're going to do is, I hope you can see that, well, there should really be a right angle in this position here. And what I'm going to do is to take the largest side that we have in the smaller triangle and the corresponding side in the larger triangle, so that's the 24. I'm going to pair these two. So the final size then is 24, the initial is 8, 24 divided by 8 is 3. A scale factor of 3 means that we multiply the smaller triangle by 3 in order to get the larger triangle. That's very useful because it allows us then to work out x. So what are we saying then? We multiply a dimension on the smaller triangle by 3 in order to get the corresponding side in the larger triangle. So the equation we'd set up would be 6 times 3 equals x, and x then is 18 units. Second example is a bit more complicated than the first one. I hope you can see that we've got two triangles, one drawn inside the other. So what I'm going to do is to separate the two triangles. Now I've separated the two triangles, I'm going to add some details onto the diagrams. This length here is 12 and this is x. This is 32. This side here, hope you can see that that's 12 plus 6, so it's 18. Something that should be added to the original diagram is that these two lines are parallel. Because those two lines are parallel, I'll just mark them on the separate triangles. We have triangles that are equiangular. So this angle is the same size as this angle because the smaller triangle fits inside the larger triangle at this point. Here are two corresponding angles, or F angles, and these angles also correspond. So the triangles are equiangular and therefore similar. Now we can proceed to the calculation to find x. Now we need to work out the scale factor. I'm going to use the formula scale factor for enlargement is final over initial. I'm going to start with the smaller shape and work to the larger shape. So the smaller shape is the initial and the larger shape is the final. We need to make sure that we have the correct sides in the formula, so I'm going to use the side opposite the angle marked with a double arc. So 18 over 12, and 18 over 12 simplifies to 3 over 2. What does that mean? It means that the smaller triangle is multiplied by 3 over 2 to get the larger triangle, or the larger triangle is 1.5 times the size of the smaller triangle. Now, I'm going to use that information to work out x. So, what will the equation be? 3 over 2 times x equals 32, because the 32 is the side on the larger triangle opposite the blue dot and corresponds with the x on the smaller triangle. Multiply by 2, so 3x equals 64, and then divide by 3, so x equals 64 over 3. This is the third and final example involving similar triangles. What I'm going to do is to mark in some angles. Now, these two angles are the same because they're vertically opposite. This angle makes a Z with this one here. These are two alternate angles, and these two angles form a Z. It's important that we mark the pairs of equal angles. Now I'm going to work out the scale factor. Scale factor enlargement. The formula is final over initial. The final shape is this one here, that's the larger of the two, and this is the initial shape, the smaller of the two. Okay, now there's one thing missing from the diagram which is essential, and that's that this is 13.5 centimetres. Otherwise we couldn't proceed with the calculation. So we need to find sides which correspond. Well, I hope you can see that the side opposite the red dot in the smaller triangle is 3 centimetres, and the side opposite the red dot on the larger triangle is 13.5. So it's these two that we're going to put together. Those are the sides which correspond. 13.5 on top and 3 on bottom gives us a scale factor of 4.5. What does that mean? It means that to get from the smaller triangle to the larger triangle, we multiply all the dimensions by 4.5. Right, what we're going to do next is to calculate the value of A. So, what do we know? Well, I multiply, well, let's make sure that we get the sides corresponding. So, the side opposite the angle marked with a single arc in the smaller triangle is A, and the side opposite the angle marked with a single arc on the larger triangle is 7.5. So these are the sides which correspond. The calculation then will be 4.5 times A equals 7.5. Now these numbers are rather awkward, but let's not worry too much about that. Divide by 4.5 and A equals 7.5 over 4.5. If I multiply the top by 2, that gives me 15. If I multiply the bottom by 2, that gives me 9. 15 over 9 simplifies. Divide by 3, that gives me 5 over 3. That's not too bad, 5 over 3 centimetres. Now I want to do something similar for side B. Now, side B is opposite the angle marked with a double arc, and the angle marked with a double arc on the smaller triangle is the 2 centimetres. So, remember 4.5 times the smaller triangle, which is to say 4.5 times 2 gives us B, and B then has the value 9 centimetres.